Hello everyone, Manas Verma here, representing Team 21, and I'm here to present our AI project, which is an AI-based career prediction system for students. This was a really fun project involving natural language processing and some hardware as well using PSP32. Our problem statement is that students from class 8th through 12th, basically from high school and middle school, often face challenges in deciding which career path they should choose. The lack of personal guidance leads to confusion, and they often choose a career path in which they don't have any skills, interest, and neither do they have any achievements in. So the solution is an AI agent that takes user input through a microphone, analyzes skills, achievements, and lifestyle using natural language processing, and provides career recommendation via speaker. So the main objective of this project is to develop an AI-powered prediction system that analyzes the user input, which we get through a microphone, and basically make a model, a personalized model, which would give uh, an optimal career path personalized for the student. We have certain assumptions here that students have a basic understanding of their skills and interests. Reliable data on achievements and lifestyle is available. Career paths and associated skills requirements are well defined. Internet and power supply is available.
Sal Patel and my roll number is 41. Now I am going to talk about PEA's framework for our career developer model. Firstly, PEA stands for Performance Measure, Environment, Actuators and Sensors. First talk about performance measure. Our career developer model is mainly focusing on three priorities. First is the accuracy of the career recommendation it is giving to the users. Second, how users are satisfied with these recommendations, and third, the accuracy of our speech recognition system of our model. Second, talking about environment, our model is working with any room, home, uh, even the places like schools or the places with background noises. It is also involving the people like students, their teachers, and their parents. Now, talking about actuators, actuators are used to give feedback to the users. In our case, we are using speakers as the actuators. And lastly, talking about sensors, the sensors we used in our project is microphone, which is used to take input from the environment. Now let's talk about hardware requirements. The microphone used in our project is INMP441 sound sensors. The speaker we used is 4 ohm 3 volt mini speaker. The microcontroller used in our circuit is ESP32 Room 32 microcontroller for the voice input and wireless communication with the server. The amplifier used in our project is MAX98357A amplifier, which is amplifying the I2S audio from the ESP32. The other components used in our circuits are breadboard, push buttons, registers, jumpers, USB cable, two LEDs, and 5-volt power supply.
Name is Divyansh Martolia and my roll number is U23CS044. Now I will walk you through our project's methodology, which includes both hardware and software integration. We started with the hardware setup where we designed a basic circuit using an ESP32 microcontroller connected to a microphone, an amplifier, and a speaker. The ESP32 was programmed using the Arduino IDE and connected to a server via Wi-Fi. Moving to the communication layer, we implemented socket programming to allow real-time data transfer between the device and the user. This ensured smooth and reliable transmission of audio input from the user to the server and back again as audio output. For speech processing, we use the speech recognize library to convert the user's voice into text. This allowed the system to understand the query. Then we used Google text to speech to convert the responses that was the career suggestions back into the audio. Next comes AI model development part. We found our dataset from the Kaggle website which was based on users' interests, skills, and preferences, and trained a birth-based classifier model. This model predicted the most suitable career path based on the processed text input. Finally, the integration and testing phase, we combined the hardware, server logic, and AI model into a seamless pipeline. We conducted a thorough end-to-end testing, ensuring the system could accurately take voice input, process it, and give meaningful spoken career guidance. With this, we successfully deployed the bot for real-time use.
Hello, my name is Sarthak Gohil. I am going to explain circuit diagram of our model. This is ESP32, which is help to audio streaming and provides a wireless connection of Wi-Fi. This is microphone. This is push button. ये एम्पलीफायर है, ये स्पीकर है. सबसे पहले सर्वर रन होता है. फिर हम पावर सप्लाई देते हैं. देन ESP32 की वाईफाई पिन और ये पिन एक्टिवेट होती है और ब्लू लाइट ऑन होती है. फिर नेक्स्ट ये पुश बटन प्रेस करते हैं, तभी माइक्रोफोन एक्टिवेट होता है और यूज़र अपनी इन्फॉर्मेशन देता है. वो इन्फॉर्मेशन सर्वर सर्वर को वो इन्फॉर्मेशन using ESP32 sends to server our Wi-Fi. Server converts this audio file to text file using Gemini API. वो टेक्स्ट फाइल को पैराग्राफ में कंसिडर करेगा, उस पर NLP अप्लाई करेगा और करियर प्रिडिक्ट करके दे देगा और आउटपुट में एक उसकी ऑडियो फाइल बनेगी. वो ऑडियो फाइल यूजिंग ESP audio file via ESP32 sends to speaker, but before it go to speaker, it amplifies audio voice to improve intensity of voice.
My name is Divyansh Martolia, roll number U23CS044, and I will be explaining the flow chart of our model. First, we will be providing a power supply to our device. Once the device turns on, the Wi-Fi gets automatically connected to the net. Now, if we want to start recording, we will have to press the push down button. Once it is pressed, the server creates a socket connection to the device. Now the mic starts recording the audio and the data is being transferred in real time to the server. Once you want to stop recording, you just have to release the button and the data transfer stops. Now the server will begin to processing the speech to text and the processed text will be sent it to the bird classifier. The bird classifier predicts the best career, and the text then is converted back to speech and send it back to the device through the socket connection, and it is played over the speaker in real time. Once the audio is done, the server disconnects the socket connection with the device, and now if you want to again start recording a new prompt, you just have to again press the button and the process will again start in the same way. Working video of our model will be explained by Pratham Maheshwari, roll number U23CS070.
This is our AI project called Carrier Prediction Model. This is a ESP32. This is a microphone. This is a push down button. This is a speaker. And this is a MAX98357 amplifier. This is INP441. ESP32, which helps to connect this microphone and amplifier, as ESP32 records recording as an input via microphone and give it back to the server. Server analyze the waveform, convert into the text, as we convert the speech into text via GTTS, and analyze the text using our career BERT model, which is using BERT based model, which helps to transform the text into tokens. Then our model tokenized into its different vectors. Our vectors are classified and analyzed purposely according to the label. After analyzing the all our vector, we score according to our label as present all our tokens in the text. After getting score, our model gives the best career path which have a high score according to the text and gets back output from a server to ESP32. We have used our socket programming to send the output via ESP32 to server and server to ESP32 because ESP32 can't store as long as much output, it has a limited flash memory. This microphone helps to record the audio, and when the gets output, our amplifier amplifies the output and give back to the speaker. Let's go into the demonstration part. When I press the button, it starts recording and send the output until I debounce the button and we get output, so this LED will be lighted. Let's go. Hello, my name is Pratham. I am in class 10th. I like to solve puzzles and my interest is in maths. Which career path should I choose? This will convert my audio waveform into text. As you can hear the output. As it gives back the output to mathematician because I have an interest in maths and solving puzzles. This is output which we can hear back into our system. I can show you as is the output dot wave which can you hear back.
Based on your input, a potential career path for you could be mathematician.
इस प्रोजेक्ट में हमने ये सीखा है कि हार्डवेयर और सॉफ्टवेयर को कैसे इंटीग्रेट करें। हमने ESP32 को खुद से प्रोग्राम किया, उसको हम कैसे कस्टमाइज कर सकते हैं वो सीखा, और सर्वर साइड पे हम कैसे खुद का लॉजिक क्रिएट करते हैं, फिर ESP32 माइक्रोफोन और एम्पलीफायर को कैसे कनेक्ट करते हैं वो सीखा। हमने टेक्स्ट टू स्पीच और स्पीच टू टेक्स्ट को रियल टाइम वॉइस में कैसे इंटरेक्शन करते हैं वो हमने सीखा। हमें मॉडल ट्रेन करने के लिए बर्ड बेस्ड क्लासीफायर का यूज़ किया है और और उसके हेल्प से करियर प्रेडिक्शन में NLP टेक्निक्स को यूज़ किया है। फिर without using socket programming we are able to send only limited amount of data, but using socket programming we can send much more data to server and get more smooth and responsive audio transfer between devices. इसको क्रिएट करने में हमने मॉड्यूल 2 को यूज़ किया है जो कि है ऑटोमेट प्रॉब्लम सॉल्विंग एजेंट। हमने मॉड्यूल 2 को यूज़ किया है ऑटोमेट प्रॉब्लम सॉल्विंग एजेंट क्योंकि ये हमारा सिंपल रिफ्लेक्स एजेंट है। मॉड्यूल 4 इंट्रोडक्शन टू परसेप्ट्रॉन न्यूरल नेटवर्क एंड डीप लर्निंग। मॉड्यूल 7 में हमने रेनफोर्समेंट लर्निंग से हेल्प ली। मॉड्यूल 9.2 नेचुरल लैंग्वेज को अंडरस्टैंड करने। यह था हमारा चतुर भी तो सिर्फ करियर प्रिडिक्ट करके देता है, बट इन फ्यूचर चतुर प्रोवाइड्स personalized learning roadmap with study resources like videos, websites, book references, and much more. चतुर एक AI है और वो लर्न करता है एंड एडप्ट करता है, so it will not guide only students towards right career path but also motivate, mentor, and inspire them at every step, becoming the friend every student deserves, especially when they feel lost or unseen. ये था हमारा चतुर। थैंक यू।